Here's a demo demonstrating 3 people logging in to the server. Type P1 and enter. P1 joins the game. As you can see, the other people not logged in yet are not notified as they are not players. P2 joins, and since P1 is the only other player, they are notified that P2 enters the arena. Next, P3 joins, and both P1 and P2 are notified. The login code starts in the main function. Within the event loop, select is used to prevent any blocking and to only progress when a client is ready. When a new client joins, they are added to the end of the client list done here. This creates and initializes a default instance of a client for the new user. They are then prompted for their name to log in. Write to client just writes the message only to the file descriptor of the client. The main logic happens in the handle client function. If the client has pressed any keys and this is their first time logging in, the keystroke gets redirected to manage username. Whatever they typed gets concatenated to their name buffer until they press the enter key, which is the new line character. That then immediately gets replaced by a null terminator. Once they completed their name, their entry is broadcasted to everyone currently logged in. They receive their welcome message while they wait for an opponent to arrive, which is done here, where the first 2 clients who have not previously battled are paired together and a match commences.
Okay, so I'm gonna show the matching functionality of the program. So here you can see that 2 players that joined, that connected to the server are matched with each other. So I'm just gonna quickly finish this match. Okay, so the match is over now. So we see that they don't match with each other again. But if I join as a different player, and we see that Bob and Joe match, but Joe and Jane don't match because they just played. Okay, so the way matches are kept track of is that we have this battle info structure. So each client keeps track of a battle info, has a kind of battle info field, which is equal to null if it's not currently in a match. Now this structure, it contains the hit points, the number of moves, the number of power moves, whether the player is active or not, whether it's speaking or not. And it also contains the battle info of its opponent. Now, the main function that deals with matching players is this match players function. So all it does is it iterates from the beginning of the linked list, and it checks when matching players, it checks to see whether they are currently in a battle. It checks to see whether they are logged in, and it checks to see whether or not they've actually matched with each other just previously. Now, once a match is made, we call this function makeMatch, which simply allocates some space for the battle info structures of each client, and it populates the structures with the appropriate information. And this obviously displays the proper messages to the clients. Now the match players function is called whenever we finish a match, right here, whenever we finish a match, it's also called whenever one of the clients drops, which is in the remove client function here. And finally, it's also called whenever a user logs on, which is up here.
This is a demonstration of a battle between 2 people. P1 starts first and they get shown a list of possible moves, while P2 waits. After P1 attacks, it is P2's turn. Now, P2 tries to attack when it's not their turn, and it gets ignored. This time, P2 does not have enough power moves, and thus P no longer works. Once a person is defeated, they both receive a message and await a new opponent. The main logic behind combat is in handle client, more specifically, in play turn. For every valid move a client can make, the corresponding action gets dispatched. For A random amount of damage is calculated and dealt to the opponent, followed by a corresponding message to both parties about the attack, ending the game if the HP of the opponent reaches 0. Otherwise, the turn changes. Likewise, for P, the code is similar to a regular attack action, with the exception that the code checks if the player can make a power move, decreasing the total number of power moves if they can, along with a 50% chance the move misses. For S, it lets the player know that they can type a message and toggles speak mode, which buffers the keystrokes for a full message. For B, it toggles mute, which prevents receiving messages from the opponent while letting them know about the mute.
Okay, so I'm gonna demonstrate the speaking feature of the project. So if a player is currently not in a match, pressing S has no effect. So any user that's not currently in a match can't speak. Now, if a user is in the match and it's an active player, then we can press S and it'll prompt you to speak, and you can enter some text and it'll indicate that you spoke. And for the inactive player, it'll say something like this: Joe takes a break to tell you, hello world. Now, if you're the inactive player, pressing S has no effect. Now, for the code, the first thing to notice is this play turn function, which checks to see whether the active user inputs S, and if it does, it checks to see whether it is actually an active player, and it checks to see whether it's already speaking. If it's not, then it prompts the user to speak, and it checks this speaking field of the battle info structure to 1 or true. Now, once the speaking field is set to true, whenever that user inputs anything else, it's basically relayed to this manage speak function, which is up here. Now, in order to understand the manage speak function, you first need to understand this message field of the battle info structure. So what it does is it's basically allocated some space dynamically, which is in particular, it's allocated this max message size macro +1 characters. And its first character is originally just set to the null terminator so that it's an empty string. Now back up here, what we do is we concatenate the string. We concatenate the text that the user entered to this message field, and we only concatenate so much so that it actually fits within the buffer. And we check to see whether a new line character has been inputted. If it has, then we simply set it to the null terminator so that it's still a string. And finally, so the way this function works is that it keeps buffering until either the user inputs a new line or the maximum capacity of the buffer has been reached. Now, if either of those are true, then we simply send the appropriate text to both the active and inactive player. We set the message field of the battle info back to the empty string, and we finally print the appropriate prompt so that the active player is prompt to give another command.
Client dropping is handled in the handle client function. When a client is dropped in battle, the match ends, which notifies the opponent and performs cleanup of any allocated memory. A message is broadcasted to everyone of the game of their disconnect. And back in handle client, the remove client function gets called, which removes the player from the linked list of connected players, frees memory, and finally closes the file descriptor.
Okay, so I'm going to show multiple matches happening concurrently. So here we've got two users, A and B, on the top two terminals playing against each other, and we've got C and D on the bottom two terminals playing against each other. So now we see here that that we see here that A and B can play against each other without it affecting C and D, and C and D can play against each other without it affecting the top two. Okay, so now the main control flow of the program is dictated by this while loop in the main function that was provided in the starter code. So here select is called. So this will block until one of the file descriptors corresponding to the sockets associated with the clients are ready to read from. Right? If a new client is connecting, then we're simply going to accept it, which doesn't involve any blocking on our part. And for any of the other sockets, we simply call this handle client function if it's ready to read. And in that handle client function, we call this read function. But since we know that the file descriptor corresponding to this client is ready to read, this read won't block. Right now, everywhere else in this handle client function, we simply check to see the attributes of this client to see whether it's in a match, whether it's active player, whether it's logged in or not, whether it's disconnected, and whether or not we need to end the match or broadcast something to everybody else. But we see that there's no other blocking involved here. So, so truly the only blocking that's happening is with this select function.
Here are some examples of trying to break the game. First is entering a zero-length name, which works fine. Second is attempting to do a buffer overflow, and this works fine as it only executes up until the max buffer length. And third is disconnecting mid-game.
So I'm going to demonstrate the block message enhancement that we added. So here the active player can press B in order to block all messages. So whenever the other player tries to speak something, this player here will simply not receive it. Now, the way this is implemented is we added this another case to the play turn function, which runs this toggle block messages function. What the toggle block messages function does is it simply toggles this mute field that the battle info structure of the client that's currently the active user has. And what the effect that that has is that when the other user tries to speak something, uh, we we check in manage speak to see whether the opposite player is muted, and if he is muted, then we simply don't send the message to that player.
For teamwork, we decided to do pair programming. I was the driver for implementing dropping and the regular attacks and power moves, with Zane as my navigator.
So in relation to contributions, I was the driver for the enhancement, the speaking, and the login, and I was the navigator for the remainder of the features.